Okay, in this lesson we're going to look at the double angle formula. Just another one of our formulas for computing quick identities between two different types of angle. So to begin with, we're going to look at the compound angle formula, which we covered in the previous lesson, which takes a combined angle of A and B and computes it as two separate angles using, for instance, this here is the sine version of it. Sine A plus B gives you sine A, and it puts each angle separate from the other. That's for ease of computation. That's when A is not the same as B, so it's two different angles. But what if we had A was equal to B? So we're taking sine of double the amount of the angle. Right, so if we just use the compound angle formula, but we change B to be equal to A, then that gives us sine A cos A plus cos B sine A, which is the same thing twice. So we've got two lots of sine A cos A. So sine of 2A, two lots of the angle, is equal to 2 sine A cos A, and if you just divide both sides by 2, you can write it like that. Right, so I'll get you to try this one for yourself. We'll just substitute in B and A, so we'll use the cosine version this time. I'll let you try and simplify cos A plus B, but if B was actually the same angle as A, so two lots of A. Alright, try that. Okay, if you need a target to aim for, see if you can get from here to cos 2A equals cos squared A minus sine squared of A. And you can do the same thing for the tan compound angle formula to get this as your double angle formula for tan. There we got that. Now often we'll use this to go from the right hand side to the left hand side to combine two separate angles, two separate terms into one single. Right, so here's an example of when we might use it. A very basic example. How do we get from sine of an angle times cosine of the same angle to a single term? So sine of 2A equals 2 times sine of A cos of A, which is the formula straight from there. And if I just substitute in what was in the angle, so we've got x inside the angle, so I'll swap that in for A. And if I just use a bit of algebra, I can rearrange it so that sine x cos x, which is what we started with in the question, can be written as sine 2x over 2. Right, a slightly tricky example, and I'll get you to have a go at this first. Right, so the bit inside the angle this time is x over 2, so that's what I'll be swapping in for A. So A will be equal to x over 2. So just substitute that in first. Then I'll rearrange the right hand side until I've got the same thing that I had in my question. So I just have to divide both sides by 2, and I'll get sine of x over 2 equals cosine x over 2, which is what I started with. So the left hand side, I've missed the divide by 2. The left hand side is now a single term answer for what I had to begin with, so that's a bit easier to compute. This is mostly just used for simplifying anyway. Right, so here's the cosine formula, and using this rule that we've seen before, it's just your basic trig identity of sine squared plus cos squared equals 1. So if I take that and I rearrange so that I've got sine squared as a subject, I can write that as 1 minus cosine squared. And if I divide both sides by negative 1 or multiply by negative 1, it gives me negative sine squared equals cos squared minus 1. And I can substitute that in where I've got sine, negative sine squared on the top here. And now I can write the cosine double angle as just in terms of cosine. So that's 2 lots of cosine squared minus 1. Right, give this a shot. Instead of getting rid of all the sines, make it all written in terms of sine and get rid of all the cosine terms in this cosine double angle formula. Right, here we go. So now the cosine double angle formula is written just in terms of sine this time. So if you want to eliminate all the cosine terms, you can write it in terms of sine. Right, this example is from the book. The reason I'm doing this example is because it can illustrate how we can use it to simplify or to work out an angle we don't know based on having one that we do. So it's a reasonably quick example, but using a few of the angles that we know. So there's a few basic ones that you'll become very familiar with, such as sine of 30 degrees, which is pi over 6, is equal to a half. At this point, the opposite is a half of the hypotenuse. Same thing with this one. At 60 degrees, the adjacent is half of the hypotenuse. So if I know that cosine of 60 degrees is equal to a half, then I can use the cosine double angle formula, this version here. When A is 60 degrees, then I'm working out cosine of 2A, so that's 120 degrees, is equal to 2 lots of cosine of A squared minus 1. Now, cosine of A is, well, we know that bit. That's the bit in the question which says that cosine of A when A is 60 degrees is a half, so I can substitute that in for a half. 2 lots of a half squared minus 1 equals 2 times a half squared 2 times a quarter. That is a half, minus 1 is negative a half. Right. The reason I used this version of the cosine formula was simple. I had cosine of 60 as the only information I had, so I used that to substitute in.